In this lesson, we're going to learn a little bit more about segments. One of the most important parts of a segment is the midpoint. And the midpoint is the point in the middle of the segment, hence the name midpoint. It divides the segment into two congruent segments. So in the diagram, you can see we have segment AC. Point B is in the middle, which is called the midpoint. And what point B does, divides AC into two congruent segments. So that means from A to B is the same length from B to C. So segment AB would be congruent to segment BC. Or if you're talking about length and equality, you would say the measure of AB is equal to the measure of BC. We use midpoint a lot in proofs moving forward, especially for next unit. A segment bisector can be a line. It's often a line, but it can be a ray or a segment that divides the segment into two congruent segments. So essentially it passes through the midpoint of the segment. So in this picture, line CD goes through point M, which is the midpoint of AB. So AM is congruent to segment MB, or the measure of AM is equal to the measure of MB. A special type of segment bisector is the perpendicular bisector. So it essentially does the same thing except for the line will be perpendicular to the segment, which means it'll be a 90-degree angle. So you can see line CD, it cuts through point M. AM is congruent to MB. And you can also see that little box right there by M, and that indicates that it's perpendicular. So it's a 90, it cuts it at 90-degree angles. So just a couple examples for this lesson, should be nice and short and sweet. It's definitely going to be important if you don't have a picture to make sure that you draw a picture. So for example 1, it says if B is the midpoint of AC. So the first thing I'm going to do is I'm going to draw AC. And I'm going to put B about as close as I can to the middle. And I'll put a little congruent mark on each of them so you can see that AB is congruent to BC. We are told that AB is 9x minus 12, and we're told that BC is 5x plus 16, and we're looking for the value of x. Because B is the midpoint and we know that the midpoint cuts the segment in half, then we know that that measure of AB, 9x minus 12, is equal to the measure of BC, 5x plus 16. And then you're going to solve this like a normal algebraic problem. So I'm going to start by moving my 5x to the left side to get it off the right side. And I'm also going to add 12 to both sides. That way it goes from the left to the right. So 9x minus 5x is 4x. 16 plus 12 is 28. Now, since that's 4 times x, we're going to divide both sides by 4 using that division property. 28 divided by 4 is 7. You want to be really careful with these questions and make sure you find what it's asking you to find. So this one said find x. I could have very easily asked you to find the measure of AB, the measure of BC, or the measure of AC. If you ever want to check and make sure you're right, try plugging that 7 back in and make sure that you get the same thing. So if I do 9 times 7, that's 63, and 63 minus 12 is going to be, what, 51? And so hopefully if I plug 7 in for BC, I also get 51. So 5 times 7 is 35, and 35 plus 16 is 51. So you can plug it in just to check and make sure that you get the same length for each segment, because if you don't, then that would definitely be an indication that you've made a mistake somewhere in your solving. And that would mean that the entire length of AC would be 102, because 51 plus 51 is 102. Again, you weren't asked to find that. It's just kind of a self-check. For example 2, we have a picture, so we don't have to draw the picture. We know that line N bisects QR, and we are looking to find QR. So this one, we're not just finding X, we're finding QR. So make sure that once you find X, you find the measure of QR. So we're told that N bisects QR, so that means that QP, which is 3x plus 5, is going to equal that measure of PR, which is 5x minus 19. Okay, so we're going to solve this by moving our 5x over to the left side and moving our 5 over to the right side. That way I get the variable off the right side and the constant off the left side. 3x minus 5x is negative 2x. Negative 19 minus 5 is negative 24. Divide both sides by negative 2. So I get x equals 12. And again, this one did not ask for x. This one asked for QR, which is the length of that entire segment. So we are going to need to find both pieces, which should be the same, and then add them together. So let's look for QP. I'm going to do 3 times 12, which is 36, and 36 plus 5 is 41. Now PR should also be 41. I'm going to plug it in just to make sure. We've got 5 times 12, which is 60, and then 60 minus 19 will also be 41. And so then that makes the entire segment QR 41 plus 41, which is 82.